In this video, we are going to learn about informed search. Before we begin, let's review our previous exercise from last week. The first exercise is about the false coin problem. Previously, you were given a task to find one fake coin among the 6 coins. So, in the previous exercise, I have given you the examples how to find the goal state on this left-hand side of the tree. And your task for this exercise is to find the goal state from this right-hand tree. Given that the combination of either C3 and C4 with C5 and C6 does not have the same weight, then we want to make sure which combinations that has the false coins. The knowledge that we got at this step is that the coin number 1 and coin number 2, they are the original coin, because we already know that one of the fake coin will be among these 4 coins. In this case, we can pick the combinations of C1 and C2 and compare it with the weight of combinations of coins 3 and coin 4. If the combinations of C1, C2 and with coin 3 and 4 are the same over here, okay, so if it's the same, then we know that the false coin, the fake coin, must be either C5 or C6. So in this case, we know that we can represent our knowledge into like this one. So now we only need to know between C5 and C6 which one is the false coin. In this case, again, we can compare it with C1 because we already know that C1 is the original coin. So comparing C1 with C5, then we can know that if C1 and C5 has the same weight, then we can know that C6 is actually the fake coin. However, if C1 and C5 does not have the same weight, so in this case, C5 will be the fake coin. Alright, let's see on the right hand side of this tree. What if the comparisons between C1 and C2 and also C3 and C4 yield not the same result? So in this case, we can be sure that the fake coin is among C3 and C4 pair. It's between C3 or C4. So in this case, we can compare C1 with C3. So in case that the combination of C1 and C3 has the same weight, in this case, we know that C4 is the fake coin. However, again, if the comparisons between C1 and C3, they don't weigh the same, in this case, we can be sure that C3 is the fake coin. So this is the solution for exercise 1. Let's see our second exercise about 4 queen problem. So in this problem, you are asked to finish up the backbreaking process. Continuing from our previous step, in this case, if this is at the stage of I equal to 1, and we put our first queen on row 2 column 1, so we know that there should not be any other queen located in the tiles that is marked with this red line. Again, after this, the stage becoming 2, I equal to 2, then we know that here is the information that we already get, right? Sorry, this one, right? So in this case, we can only place the second queen on the row 4 at the column 2, this one. So if this is the case, then we will not be able to place any other queen on this line, the one marked with red and also orange. You will see that we will have a very limited option to place our queen. Right? So in this case, when I equal to 3, I equal to 3, we are only left with one spot, right, to place our third queen. That would be on the row 1, column 3. Let's see here, let me draw the line. Okay, so in this case, we can only put our third queen over here. And then, okay, for our fourth queen, we only have one place that we can put it, is over here at row 3, column 4. This is happen when I equal to 4. So in this case, we already found the solution for this 4 queen problem by using backtracking mechanism. Next, let us see the solutions for this missionaries and cannibals problem using depth first algorithm. So from the previous step, we know that we should not expand, we should not choose to move, that we will move one missionary and one cannibals over from the west bank or from the east bank to the west bank. Why? Because in this case, the number of cannibals will be larger than the number of missionaries, and then the missionaries will be eaten by the cannibals. So in this case, we can only move two cannibals over. So once we move two cannibals over here from the east bank to the west bank, then we can only make one move, right? We can either move one cannibal or two cannibals back. But since we cannot move two cannibals back from west bank to east bank, in this case, we can only move one cannibal. So once we move one cannibal from the west bank to the east bank, then the only options that we can choose, let's say in this case, we choose to move two missionaries over from the east bank to the west bank. It leads to this state. And then from this state, we move one missionary, one cannibal from the west bank back to the east bank. Then we got this state. From this state, we can move over two missionaries from our west bank to the east bank. This one. So this will be our latest state. And from these conditions, we can only move one cannibals from our west bank back to the east bank, so that we will not violate the rules of the game. So from this state, we can move two cannibals over. So our state will be, we have three missionaries, two cannibals on the west bank, and then we move back one cannibals over from the west bank back to the east bank, and then in here at this last stage we move the final two cannibals over from the east bank back to the west bank, so that we can reach the goal state, this one. So this is the solution for exercise 3. Let's see exercise 4. You are asked to find the solutions tracing from A to find the goal node, which is G2, using depth first search. Remember, in depth first search we use last in first out, the concept of stack. So in this exercise, in this slide, it will only shows the continuation from the previous solutions. If, let's say, if G1 here, G1 from our open list to the closed list, since we know that G1 here does not have any other child node, right? So it should move back to the parent, to its parent node, back to the root node, and then we go back to C here. That's why in our open list here, we can see node C over this. Then we move this C from our open list to closed list, then we get two nodes, F and H. We put this F and H into our open list. And then from here, we pick node F, we move it from our open list to our closed list, and then we get node L and M. We put node L and M in front of node H. Remember, this is last in, first out. So in this case, since L is in the front of the list that in the front of our open list, so in this case we can pick this node L, move it from the open list to the closed list, and then we know that since this node L does not have any child node, so we will left the state becoming like this one. We are left with node M and H. Similarly again, we continue move node M from the open list to the closed list. Still, we know that node M does not have any child node. Then that will only leave us with the node H at the front of our open list. So from here, once we move this node H to from our open list to the closed list, then we will get the goal state, the goal node, which is G2 inside inside our open list. So in this case, we know that the root from the root node, which is A, to the G2 will be A, C, H, and G2. This will be the solutions that we have. Let's see. So for exercise 5, so we're back again to the missionary and cannibal problem. However, in this case, you are asked to finish this problem using breadth first search or BFS algorithm. Okay, so continuing from the previous example on the past week video. So in this case, continuing that if we choose this moving one missionaries over from the west bank to the east bank, then we can get the following combination, right? If we move one missionaries, two missionaries, one missionary, one cannibal, two cannibals, and one cannibals. Okay. So since if we move one missionaries from the east bank to the west bank, it does not make sense. So this should not be chosen because it will only lead to the parent node of the previous stage. Again, we also cannot choose two missionaries from the east bank to the west bank because in that case, then one missionary on the east bank will be eaten by the two cannibals. The same also happens, we cannot move one missionary and one cannibals because the missionaries on the west bank will be eaten by the two cannibals. So in this case, we can only have to move left, right? Either to C or C. So let's see. Since we are doing the preferences, so in this case, we must explore all kind of alternative solutions, all alternative paths. So in this case, what if we move to C from the east to the west? So we get all three cannibals over on the east bank and three missionaries on the three cannibals on the west bank and three missionaries on the east bank. And if we move over one cannibals here, this path should not be chosen. Why? Because it has already occurred somewhere else on top of the tree. So we don't want to generate the child node for this solution. Continuing from this state, we know that we can only make two moves, right? Either we move one cannibals or two cannibals over from the west bank to the east bank. So in this case, let's see if we move one cannibals, we will get this state. But if we choose to move two cannibals over, then we will have this state. Again, this state will not be chosen. Why? Because it will show a loop. It will result in a loop back to its parent state. So we choose move one cannibals from the west bank to the east bank. And then from this stage, we know that we can make four moves, either moving one missionary, two missionaries, one missionary, one cannibal, or one cannibals from the east bank to the west bank. Please be reminded that we cannot move one missionary, one cannibal, and cannibals from our east bank to the west bank because it will lead to a game over and a possible loop. So in this case, we can only choose to move two missionaries over. So after we move two missionaries over here, again, we will be faced with five possible options that we can take. Either moving one missionaries, or two missionaries, or one missionary, one cannibal, or two cannibals and one cannibals from our west bank to the east bank. So notice that here in some options such as moving one missionaries, two cannibals and one cannibals over from the west bank to the east bank should not be chosen because it will lead to game over. It will lead to the number of cannibals outnumbering the missionaries. And obviously we cannot choose the same moves that have been made previously because it will cause a loop. So in this case, we can only move one missionary and one cannibal over from the west bank to the east bank. So we get this state. Again, from this state, we have five options that we can take. And again, some of the options should not be chosen because it will lead to either game over or creating a new loop. So in this case, we can only choose moving two missionaries over from the east bank to the west bank. So we get this stage, right? And continuing here, from this stage, we only have four options of move, four moves that we can make. I don't need to explain which move that should not be chosen because it will lead to the predictable result, which is a game over. And obviously, we should not make the same move as the move that has been made previously because it will lead to a loop back to the parent state. So we are only left with this move, moving one cannibals over from the west bank to the east bank. And then from here, I'll just simplify things, right? So this move should not be chosen. So we get to move two cannibals over from the east bank to the west bank. We get this stage. From this stage, we have five options of moves that we can make. So what we want to do is we will eliminate all possible moves that could lead to game over and loop. So even though we know that we still need to generate them over, we still need to write them off, but we will not expand upon this node. Okay, so that's left us with either moving one missionaries from the west bank to the east bank, or moving one cannibal from the east bank to the from the west bank to the east bank. Sorry. So in this case, we can find we go back our tracing start from the leftmost child first in PFS. So we can only move, in this case, we can only move one missionary, one cannibal from the east bank to the west bank because all the other move either create a loop or either it will spell a game over. Meanwhile, if in the previous stage the move taken is taking cannibals from the west bank to the east bank, so the only move that we can make is we move two cannibals at the same time from the east bank to the west bank, and it will give us the goal. Meanwhile, the other if we move one cannibals, so it will just create a loop for us, so we can just ignore the expanding itself. Right. So in this case, we also know there are two possible goals that can be created in this three missionaries and three cannibals problem. Alright, so exercise 6 talking about tracing the root of this tree using PFS from A and finding the N, finding the goal. Okay, so we'll just continue from where we left off in the last video. So we know that there is in our last state we visit this node G2. So we know that from our last stage in the past video, we have visited G2. This is our current location. So in this case, we want to move G2 from our open list to go to the closed list. Remember that in PFS, it will use the methodology of first in, first out, or the methodology that is used by Q data structure. Alright, let's see next what will happen. So from G2, we know that we can get L and M. So we write both L and M at the end of our open list, because actually this breadth first search or PFS, it follows the first in first out concept as in the Q data structure. Okay, let me continue. After moving G2 from our open list to the closed list, then what we want to do is in our open list we move the F to the closed list, and then after that we have already expanded F, we go back to I, to here. We start the iteration on I. So in here, the open list here is pretty straightforward, because you can see that I is located at the front of the open list. So we can just move this I to the closed list, and then we'll get nothing, right? Because basically I does not have any child node. Similarly, we have J here. We move J from our open to the closed list. Then we know that since we know that J does not have any child node, so it will also be offer for J. Next, we'll find with G1. Actually, G1 is the solution for the previous question. However, in this case, G1 and G2, they are not the final nodes that we are going to trace. So in this case, we move our G1 from the open list to the closed list, and then we get K, L, M, N, and O in our open list. So in this case, what we want to do here is we move our K to the closed list, and then we got L, M, N, O. Again, so from L, M, they don't have any other child node. So here, step by step, I'm moving L, this one, and then in here, I move M, right, from the open list to the closed list. And then after that, we get back here to N. Since N is already in the front of our open list, and it is the goal state that we want to reach. So in this case, we don't need to put this node N back to its closed state. So just leave it over here, and then that's it. This is the solution for the breadth first search. So in this case, we can know that the solution will be N, F, C, A. Okay, so that's it. Review for the previous 6 exercises.